So we're going to start explaining the triangle A prime, B prime, C prime in brown, and a particular inconic that I'm selecting by dragging this point O prime, which defines the center of an inconic to A prime, B prime, C prime. And the inconic is being shown here green as an ellipse. The inconic is an ellipse provided that I stay within the medial triangle of that triangle. And I'm also reporting C sub 0 here, which is the centroid of this triangle, which I'm calling the base triangle, A prime, B prime, C prime. Okay? Now, since I can always draw the circumcircle of this triangle, this black thing here, I now have an implied Poncelet porism because I could think of a porism inscribed in the circumcircle and circumscribing this particular conic, right? So I can show this family of blue triangles here, and I'm labeling its vertices A prime, A, B, and C. Okay, and obviously, as I run through this whole family, I'm going to at some point traverse the base family, A prime, B prime, C prime. So, I'm building a Poncelet porism starting with the brown base triangle. Okay, now where am I going with this? Let's stop this if I can. Can I stop this guy? Yes. Okay, so I can stop this animation. Okay, now let's explain the other parts of the simulation. I'm also showing here, just for reference, this vertex CEQ, which is where C prime would have to be for A prime, B prime, C prime to be an equilateral triangle. Okay, but clearly A prime, B prime, C prime is not equilateral, and in fact, you can see here that its centroid deviates from the circumcenter x3. If A prime, B prime were an equilateral, these 2 points would have to coincide. Now, the final thing that I want to talk about is this particular axis here involving x74, the orthogonal conjugate of the Euler infinity point, x30, which lies on the circumcircle, and x110, which is the antipodal or the antipode of x74 on the circumcircle. And this thing on Kimberling's ETC is known as the focus of the Kiepert parabola. Those details are not germane here. Now there's this axis. These 3 points are known to be collinear, x74, x3, and x110, and a bunch of other points. But again, that's not germane. The only germane thing here is that these 2 points are antipodal, x74 and x110 on the circumcircle. Now, as we saw before, by jogging through the Poncelet family, this axis is rotating in some particular way, which again, the details don't matter. It's rotating with some velocity, variable velocity. But the main thing to notice here is that it is not stationary over the family, right? Now, the main observation in this video is the condition, a particular condition that makes this axis become stationary, and that is for A prime, B prime, C prime, the base triangle of this family, to be an equilateral. So I'm going to make that be the case by making C prime be exactly on top of that construction vertex CEQ. So I'm just going to make one go on top of the other, and I'm just going to jog the family, and you're going to notice that the axis x74, x110 has become stationary. Let's vary the center of this particular inconic, so you can see that this phenomenon occurs for any inconic. So if a circle-inscribed Poncelet family, this is how one would state this observation. When a circle-inscribed Poncelet family, circumscribing any generic caustic, contains an equilateral triangle, it seems like the axis x3, x74 becomes stationary. You can see here that the centroid C sub 0 now coincides with the circumcenter as required by an equilateral triangle. C sub 0 represents the centroid of the equilateral. And up here I have that top vertex C prime coinciding with C sub EQ. Okay, so again, if I take C prime now and I disconnect it from that equilateral construction vertex over there, as so, you can see here that no longer is that axis stationary. Let's make it even more separate, maybe here. Okay, so the axis is not stationary for any chosen inconic. And the axis becomes stationary if the triangle, there is an equilateral triangle in the family. So, you know, for any chosen inconic, and there's a two-dimensional family of such inconics, because what you're seeing me do here is just specifying its center, and I'm remaining within the medial triangle of the equilateral so that this inconic does not jump to a hyperbola. So we thought this was a pretty cool condition for the stationarity of this axis x3, x74. Okay, I'll see you on the next video.